So convolution theorem states that if f of t and g of t satisfies the condition of the existence theorem, mean number one, they are piecewise continuous, number two, they are of exponential order. If these two functions satisfy the condition of the existence theorem, then convolution of f convol g is going to be defined like this: 0 to t f of tau gt minus tau d tau. And in the previous lecture we have couple of properties of the convolution. So convolution is commutative, it is associative, it is distributive, and some properties more. It is last time I have mentioned convolution is an alternative of partial fraction. If you are finding the inverse Laplace transform, for example, if this is 1 over s square plus 1, s square plus 4, for example. So, if I have to find inverse Laplace transform, I have partial fraction. So far I have discussed. So you can write this as as plus b because both are quadratic factor in the denominator. But if you are not going to do this, then you can find Laplace inverse through convolution. Number one. Number two, convolution is used to solve integral equation. Integral equation or integro-differential equation. Integro-differential equation. So this is the second point of the convolution. First, it is an alternative of partial fraction. The second is it is used to solve integral equation. Now we shall see a few integral equation and we are using the property of convolution to solve. Example, solve the following integral equations. Now the integral equation is an equation in which the unknown function is under the integral sign. So the unknown function must be in the integral sign. Let me solve two questions here. This is the integral equation because this is unknown function. Unknown function is under the integral sign. So solution, writing step 1 is writing in terms of convolution. So this is written in terms of convolution. F of t as it is plus f of t convolve t is equal to t. So this is the way you are writing this integral in terms of convolution. You have seen the definition there. F convolve t is f of tau gt minus tau d tau. The limits are 0 to t. So this is you are writing. This is the first step. Every integral equation, integral differential equation, you are writing first step as writing in terms of convolution. Now taking Laplace transform throughout. So Laplace transform of f of t plus Laplace transform of this convolution is equal to Laplace transform of t. Now Laplace transform of convolution is equal to product of their Laplace transform. Once you have this Laplace, it is going to be a function of s plus here Laplace of f into multiply by Laplace of t is equal to 1 over s square. So Laplace transform of the convolution is product of their Laplace transform. So this is written f of s plus f of s into Laplace of t 1 over s square is 1 over s square. Let me take an f of s common here. I would left 1 plus 1 over s square is equal to 1 over s square. Let me have the LCM. This is s square plus 1. F of s is equal to 1 over s square. This I have. S square goes, so 1 over s square plus 1 is capital F of s. Since our function is t, we have to find answer in terms of t. So taking inverse Laplace transform. So f of t is sin t this time, because you know Laplace of sin t is 1 over s square plus 1, and if you are taking Laplace inverse, this will be sin t. F of t is equal to 3t square minus t minus 0 to t f of tau e t minus tau d tau. Again, this is integral equation because this is unknown function which is under the integral sign. So first step is writing in terms of convolution. This f of t as it is equal to 3t square minus t minus. So this I am writing in terms of convolution, which is f of t convolve et. So if I am going to have convolution, I'll get this back. F of tau et minus tau d tau by definition. Now taking Laplace transform. This is f of s is equal to 3 times Laplace transform of t square minus Laplace transform of the product, convolution of the convolution. This. Now on the left, Laplace of small letter going to be with the function of s. So there is no note, f of s. F of s is equal to Laplace of t square is 2 factorial over s cube. This is the Laplace transform. We know that Laplace transform of Tn is equal to n factorial over s n plus 1. So with the help of same formula, 2 factorial over s cube minus Laplace transform of e minus t is 1 over s plus 1 minus Laplace transform of f of t into Laplace transform of et, because Laplace transform of convolution is product of their Laplace transform. 6 over s cube s plus 1 minus Laplace of this, which is f of s, into 1 over s minus 1. This is going to be. Now you are going to take this term here on the left hand side. F of s plus f of s into 1 over s minus 1 is equal to 6 over s cube s plus 1. Now f of s is taken out, which is common. You are left with 1 plus 1 over s minus 1 is equal to 6 over s cube minus s plus 1. So f of s as it is, this become s minus 1 LCM. This is s minus 1 plus 1 is equal to 6 over s cube minus 1 over s plus 1. This plus and minus 1 goes. You are left as s minus 1. F of s is 6 over s cube minus 1 over s plus 1. Now multiplying by s minus 1. Multiply by s minus 1 throughout. We are left f of s is 6 s minus 1 over s cube minus s plus 1. This we have multiplied. Now let the coefficient of f of s is s. Dividing by s. Dividing by s. We are left with 6s minus 1 over s4 minus s minus 1 over s into s plus 1. F of s is equal to 6s over s4 minus 6 over s4 minus s over s into s plus 1 plus 1 over s into s plus 1. I have this s divided by both and then minus minus plus 1 divided by both. So this is going to be, this s goes. Here 6 over s cube, 1 s goes. Minus 6 over s4 minus s plus 1. So here two factors which are linear, you can either the convolution theorem, I mean let you are going to have 1 over s is one function, 1 over s plus 1 is another function, or you can have partial fraction. So you can have anything which you can do which is s plus 1 and s. I have the partial fraction. So you can have partial fraction, linear factor both, putting s is equal to 0, finding one constant, the other s is equal to minus 1, the other constant, and putting back to getting this. Now f of s, taking inverse Laplace transform. Taking inverse Laplace transform. So this is f of t. Now this Laplace inverse. Let you are looking at this. We have again, let me have Laplace transform of t n is n factorial over s n plus 1. Let me have n is 3. It means t square. Laplace of t square is 2 factorial over s cube. Look at that. S cube is there. Let me write 1 over 2 factorial t. So Laplace t raised to power n is n factorial over s n plus 1. We have to find Laplace inverse 1 over s cube. It means to make it cube where n is 2. Laplace t square is 2 factorial over s cube. So it means if I am here, I would like 1 over 2 factorial. So Laplace inverse 1 over s cube is equal to t square over 2 factorial. Similarly, Laplace inverse 1 over s4 is equal to t cube over 3 factorial. If we are n is 3, Laplace of t cube is 3 factorial over s4, it means that. So once you are taking the Laplace inverse, 6 is taken out, Laplace inverse 1 over s cube minus 6 is taken out, Laplace inverse 1 over s4 minus Laplace inverse 1 over s plus 1 plus Laplace inverse 1 over s minus Laplace inverse 1 over s plus 1. So Laplace is a linear operator. Similarly, the inverse Laplace transform is a linear. We have Laplace inverse of this and this each term. So 6 is there. Laplace inverse 1 over s cube is t square over 2 factorial. Minus 6 is there. Laplace inverse 1 over s4 t cube over 3 factorial. Minus, it is e minus t. This is Laplace inverse of 1 over s is 1 minus e minus t. So let me simplify this because this formula is highly used. So you can do it. F of t is equal to 3t square minus 3 factorial is 6. That cancelled. Minus t cube minus e minus t and e minus t is minus 2e minus t plus 1. So this is the solution of the integral equation in which the unknown function is under the integral sign as well as you are using convolution to solve. let us solve a problem in which you will see how to sketch. So the question consists of three parts. Part A is f of t is 1 minus unit step t minus 1. Sketch the function and find its Laplace transform. This is part A. In part B, he has defined gt as 0 to t f of xi dxi, where f of xi is a function defined in part A. Sketch the graph y is equal to gt as well as find the Laplace transform of gt. Third part is let h of t is gt minus 1 unit step t minus 1. He has given a function like this and he said sketch the graph of y is equal to ht and then find its Laplace transform. So you will see how to sketch this time. A part. F of t is 1 minus unit step t minus 1. Let you have a graph for it. Since there is one unit step function is there, let you start t less than 1 greater equal to 0. If t less than 1, according to the definition, that is 0. So 1 minus 0. And if it is, next you are writing greater equal to 1. If it is unit step at t is equal to 1, it is on. Its value is 1 and 1 minus 1. 1 minus 1 is 0. So you have to sketch like this is t, this is 1, 0, here f of t. When t lies between 0 and 1, it is 1. 0 and 1, it is 1. Look at that, this is 1. When t lies between 0 and 1, function is 1, and when t greater than equal to 1, it is 0. So this is going to be the graph. Let's find it. Laplace transform f of s is Laplace transform of 1 minus Laplace transform of unit step function. Laplace transform of 1 is 1 over s, and for unit step function it is this. Because we have seen the Laplace transform unit step function is 1 over s e minus as. A is 1 this time. So part A is complete. B part. G of t. G of t is 0 to t f xi dxi. So if 0 to t f xi dxi, can you write this in terms of convolution? Yes, you can write. In terms of convolution, 1 convolve f of t. This you can write. Because if you are applying convolution, this is f of t minus tau, which is 1. And this is f of xi or tau. So you are getting this thing back. Where 1 is constant. If it is t minus tau, it is 1. So you are getting this. Now taking their Laplace transform. Taking its Laplace transform. So we are left g of s on the left hand side. Laplace transform 1 convolve f of t. So Laplace transform of convolution is product of their Laplace transform. 1 into Laplace of f of t. So Laplace of 1 is 1 over s into Laplace of f of t is f of s. But f of t is given in part A. In part A. So f of s, we have found this. This is f of s in the part A. Put in the value. 1 over s is there. This is 1 over s minus 1 over s e minus s. Because f of s we have in part A. So here f of s is replaced by this. So let me multiply 1 over s square, 1 over s square, e minus s is your gs. If I have to sketch, I have to bring it in terms of t. Taking inverse Laplace transform. So we are getting g of t is equal to t minus 1 unit step function t minus 1. Because here we have used second shifting theorem. Because e minus s, it will be unit step t minus 1 and the function is going to be shifted to t minus 1. So this is the second shifting theorem you have. So g of t is equal to t minus 1 unit step t minus 1. Let me have a table for it for the sketching. So if t is less than 1, greater equal to 0, this is the way I have to start. T less than 1. If t less than 1, this unit step 0 and it makes this 0, so you are left t. If t greater than equal to 1, so the unit step is 1, you are left with t minus 1, which is t minus t plus 1, this goes 1. So greater equal to 1, it is 1. So if you sketch, so this is 1, 0 and this is t. And this is your g of t you are sketching this time. When t lies between 0 and 1, it is t. 0, 0 and it is 1. A linear function like this and greater than equal to 1. When t is greater equal to 1, value of the function is 1, which is this. So a ramp function. A ramp function is there like this. T and 1, this is a ramp function you have defined. Now third one, h of t is this, where gt is defined in part B. Sketch and find its Laplace transform. Let me have third part. For third part, h of t is equal to g of t minus gt minus 1 unit step t minus 1. Let me have the Laplace transform, which is g of s minus g of s e minus s. This is the way. I have used second shifting theorem to find the Laplace. The function is gt. Its Laplace transform capital Gs, and because of the unit step it is e minus s. Now we have Gs defined here. This is the Gs. Putting the value of Gs, which is 1 over s square e minus s. This is Gs. Again 1 over s square e minus s. Let me simplify. This is 1 over s square e minus s minus 1 over s square e minus s plus 1 over s square e minus 2s. The bases are same powers are added. I have this. One more step, which is 1 over s square minus 2 over s square e minus s plus 1 over s square e minus 2s is my h of s. He said find the Laplace transform. We have finished one part, so we have find the Laplace transform. Now we have to sketch. For sketch, we have to take inverse Laplace. Take inverse Laplace transform. Inverse. Once you have a function of t, then you sketch. Inverse Laplace. This is t. Laplace of t is 1 over s square. So inverse Laplace transform will be t minus 2 t minus 1 unit step t minus 1. Because of this, I have written unit step and the function is switched to t minus 1 plus t minus 2 unit step t minus 2. Because of this, the function is t whose Laplace transform is 1 over s square. So that is replacing t minus 2. Now for sketching, I have a table. Since there are two unit step function, let me have t less than 1. I have to start greater than 0, t less than 1. If t is less than 1, this vanish according to the definition of unit step function. And if it is less than 1, obviously it is less than 2. So both parts 0 we are getting t. We are getting t, but with this are 0. The next is t less than 2 greater equal to 1. The next is. If t less than 2, this is the according to definition, this part vanish. and we are left with, let us simplify here and putting there. This is t minus 2, t minus 1. If t is less than 2, this part vanish, and if t greater equal to 1, unit step is 1. Its value is 1. So t minus 2, t minus 1 is t minus 2t plus 2, which is 2 minus t. So this part is 2 minus t. If t is greater than equal to 1, less than 2. The third is t is greater equal to 2. Third part. If t is greater equal to 2, it means it is greater than 1 as well. So we are left with t minus 2t minus 1. Greater than 2 means it is greater than 1. Its value is 1. Its value is 1. And the rest of the t minus 2t minus 1 plus t minus 2. The coefficient are remaining, unit step going to be 1. This is t minus 2t plus 2 plus t minus 2. And I hope so it vanish. 2 goes and this goes. And you are having 0. So this is the way you have to sketch the function bringing in terms of t by taking their Laplace and draw the figure. Let me have the figure. This is t. This is 0, 1 and 2. And here h of t I am sketching. When t lies between 0 and 1, it is t. So this is t. Sorry. It is t. Here. This is 1. This is t. If it is t lies between 0 and 1, value of the function is t. And if lies 1 and 2, it's 2 minus t. Let us sketch. When t is 1, t is 1, it is 1. When t is 2, it is 0. So this is going to be the 2 minus t graph, and this is t. When t is 1, it is 1. When t is 2, it is 0. Look. And when t is greater than equal to 2, it is 0. 0 is going to be shown like this. So this is the graph of the third part, which we have solved by using convolution, first shift, second shifting theorem, and then sketching. And you will see, once you are going to sketch, you have to bring the Laplace inverse, bringing your function in t, and then see how many unit step function are there. If there is only one unit step function, you are starting with 0, less than t, less than 1, and then t greater equal to 1. Do not have a, if there is one unit step. If there are more, then you have to look this pattern, and according to that, these are the value of the function in that interval, sketching and getting the answer.